Okay, let's look at these four factors and relate them to the collision theory. So I'll have, I'd say, state, or the nature of the substance, and that's going to relate to their ability to collide. And then we've got concentration. And if you increase the concentration, then you're going to have stuff more likely to collide. You can increase the temperature, and that's going to increase the energy. And if you increase the energy, when the two things run into each other, they're more likely to be able to break their own bonds, so they can reform new bonds. And then the last one is add a catalyst. And that has to do with orientation. So we talked last week about the energy level diagram, and the catalyst lowers this activation energy. The way it does that is by lining up the molecules so they run into each other easily. What are the requirements for something to be considered a catalyst?
It's not consumed or anything.
Yep, not consumed, and increases rate of reaction. So I've got a temperature Fahrenheit, a joules, a moles, a Kelvin, a kilojoules, and a mole. So I think right away I'm going to turn this into negative 2200 joules per mole. So we've got the joules and mole, or the joules and kilojoules taken care of. And then this 62, is it minus 32 then times 5/9? Or is it multiply 5/9? Well, let's find out.
I think it's that way.
Okay. So what temperature should it be about in Celsius if it's 62 degrees Fahrenheit? So 62 is kind of room temperature, right? Little chilly room. 37 is body temp, so
30-ish.
like 18-ish.
16 point something, wasn't it?
Let's find out.
16.666.
Yeah, that's it. So 16 point, I'll just say 7 degrees Celsius, and then add 273 to that. You get 289.7 degrees Celsius. Okay, so I'm going to take my negative 22, oh yeah, thanks, not Celsius. Okay, I'm going to take my negative 2200 joules per mole, and then I'm going to subtract off 289.7 Kelvin, and I'll take 9 joules per mole Kelvin. Kelvins will cancel. I'll have joules per mole in my answer. And what do we got here? Negative 2200 minus 289.7 times 9. Really? What'd you guys get? Negative 48.7? Okay. So like negative 5 kilojoules per mole for my answer. And spontaneous? Very spontaneous? Okay. What are the orders for the reactions in this trial up here? Okay, so which trials did you pick?
Well, for B, well, for A, 1 and 2, right?
So I've got no change here, and I've got a doubling effect here, and I've got a doubling effect here. So then it's first order with respect to A, since they both change by the same factor. And then for B, I'll go here, and I had a 0 change for A, And here I've got a doubling for B. And what do we have for, what is that, 4 times? Yeah, so this is 4 times. So then it's second order with respect to B? We good with that? I had a doubling of the concentration, but the rate changed by a factor of 4, so then the exponent controlling that must be a 2. All right, let's do trials 1 and 2 again for this next one. And so here, I had an increase of 0.5, let's say 1.5, and the rate here had an increase of 1.5. So it's first order with respect to A again. And then if I look at B, what I've got going on is, I'll pick these two, 1 and 3, and I got a 0 change there. And here,
Oh,
I've got a 3 time change for the concentration, but this rate from 1 to 3 changed by a factor of 9. So 3 equals 9 when it's squared. So again, second order with respect to B. We go with that?
That's not a 10 now?